Now here I have a right circular cone. Now why is it called a right circular cone? Because if you take a cross section, look at that, cross section is a circle. If you take any cross section anywhere, it's a circle. So tell me, if I have a tank like this, if I take a layer of liquid there, that layer will be a disc again. That's right. But the difference here is, in the case of the earlier tank, that disc, wherever you take, had the same radius. The radius remained a constant. But in this case, if you take the layer at different positions, its radius will not be the same, will it be? Now, let me see if I can show that to you, if I can get this marker. Alright, if I take a layer like this here, that will be a disc of certain radius. But if I take another layer there, its radius will be different. That means as you go from the bottom to the top and you take layers after layer, each layer will have a different radius, but each will be a circular disc. Alright. So, the tank is conical in shape with its vertex at the origin. So, we would keep the tank in such a way that its vertex, well, you understand the meaning of what the vertex is. Well, if this is our cone, this is the vertex. So, this is the vertex. We will keep the vertex at the origin. So that's the origin, that's the x-axis, and that's the y-axis. The tank is 3 meters high, so that distance is 3 meters. This is 3 meters. And it is 4 meters across. What does that mean? It is 4 meters across. That means this distance is 2 meters, that also is 2 meters. So if you cannot see these writings, watch again. The height of the tank is 3 meters. So this is 3 meters. That height is 3 meters. And the tank is 4 meters across, means at the top of the tank, that distance is 4 meters. So if this is the center, this is 2 meters, and that is 2 meters. That's the meaning there. And the tank is filled with water. There you go. Now we take a layer of thickness dy at a distance y above the origin. So we take a disc somewhere here. There you go. And remember that layer will be actually a disc. Is that right? So we take a layer of thickness dy at a distance y from the origin. That's your y. And we go through the normal calculation. We find the weight of that disc. We then need to lift that disc out of the tank and so on. But before we do that, we need to deal with the radius. Remember, the radius will be different for different layers. So the radius of the disc need to be expressed as a function of y, because as y changes, the radius will also change. Now this layer of disc has a radius r which changes with y. That means this radius r need to be expressed as a function of y. We need to express this radius r as a function of y using the properties of similar triangles. If you look at this diagram, can you notice there are two similar triangles that involves the distances that we are interested in? What are the two similar triangles? Look at this triangle here. That is a right triangle, and this is another right triangle. They are similar. Well, similar means they are equiangular. Is that right? Because these are 90 degrees angle, these two angles are the same, and this angle is common to both the triangles. That means the angles of these two triangles are equal. I'm going to name these triangles. So consider the right triangles OAB. This is the right triangle OAB, and OCD. Now these are similar triangles because these two are equal. They are both right angles. Angle B equal to angle D, and angle O is common to both. That's right. So the angles are equal, and so they are similar. And what is the property of similar triangles? If you have two similar triangles, then we say their corresponding sides are proportional. What's the meaning of corresponding sides? Corresponding sides are sides opposite to equal angles. For example, angle B is equal to angle D. That means the side opposite to angle B is Y in this triangle, and the side opposite to D is this whole distance. That whole distance. That's right. How much is that? That whole distance is 3 meters, the height of the tank. So the side opposite to D is 3 meters, and the side opposite to B is Y meter. And these two angles are equal, therefore these two sides are corresponding. 3 meter corresponds to Y meter. Now, since angle O is common to both, the radius R or side AB correspond to side CD, that is 2 meter and R meter. Now how do we write that? Corresponding sides are proportional means if you write a ratio, if you take a ratio of R over Y in the small triangle, it must be equal to 2 over 3 in the big triangle. So in triangle OCD, CD equal to 2, OC equal to 3. And in triangle OAB, AB equal to R and OA equal to Y. The ratio of the corresponding sides are equal. That means I can say 2 divided by 3. 2 divided by 3. What is the side corresponding to 2? That is R. What's the side corresponding to 3? That is Y. So 2 divided by 3 equal to R over Y. Watch again. Corresponding sides. The side in the small triangle corresponding to 2 in the big triangle is R. The side in the small triangle corresponding to the side 3 in the big triangle is Y. That is 2 over 3 equal to R over Y. Now you can represent R as a function of Y. Therefore R equal to 2/3 of Y. It's a very important skill in problems like this. So wherever we have R, it can be replaced by 2/3 of Y. That means wherever this layer is, its radius will be 2/3 of Y. Radius will change with Y. Okay, so we got R of Y equal to 2/3 Y. Now another way to find R as a function of Y is to find the equation of the line OD. If you want to find the equation of the line OD and solve for X, you can try this on your own. How do you find the equation of the line OD? I can give you some hint. Now O is the origin, that is 0, 0. And what are the coordinates of D? The coordinates of D are, since this is 2 meter, X equal to 2, Y equal to 3. So the coordinates of D are 2, 3. So find the equation of the line that joins 0, 0 and 2, 3. That will be the equation of this. and then solve for x, because that is the distance x. That will give you the same. Try that on your own and see whether you can produce the same result. R of y equal to 2/3 of y. Alright, now what is the volume of the disk? Now we spend so much of time now to express that radius as a function of y, because the volume involves that radius. The volume of the disk is pi r squared dy. Alright, so the volume of the disk is pi r squared dy, but r need to be replaced by 2/3 of y. So that will be pi times 2/3 of y all squared dy. And simplify that, that will be 4 pi over 9 y squared dy. That is the volume of the disk. Well, what is the mass of that disk? Mass of the disk is volume multiplied by density. This is water, and the density of water is 1000 kilogram per meter cube. So that will be 4 pi over 9 y squared dy times rho, and rho is 1000 kilogram per meter cube, and multiply that, it will give you 4000 pi divided by 9 y squared dy is the mass of the disk. Alright? What can you find once you know the mass? Now you can find the weight. What is the weight of the disk? Weight is mass multiplied by g. So that will be, this is mass multiplied by g is 9.8, and let's multiply that out. That will be 39,200 pi divided by 9 y squared dy. This is the weight of the disk. Now what is the significance of weight? Well, weight of the disk is a measure of the force that needs to be applied so that that disk of fluid can be lifted up. So this is a measure of the force that needs to be applied to lift this fluid up. That's right. Therefore, the force needed to lift the disk of water out is 39,200 pi over 9 y squared dy. Now, what is the distance that this layer has to be lifted in order to pump it out? The disk is lifted through a distance of, this is the distance through which the disk has to be lifted so that it is taken out of the tank. Now, this height of the tank is 3 meters, and the distance of the layer from the origin is y meter. Therefore, the distance through which this layer has to be lifted is 3 minus y in order that it may be pumped out. So, this force is going to lift that layer through this distance. Therefore, what is the work that needs to be done to do that? dW equal to force, that is this, multiplied by the displacement, that is 3 minus y, and let's rewrite that. When you rewrite that, the dy will come at the end, and y squared can be distributed. Is that right? Well, I have written with dy at the end, and we can also distribute this quantity. This is a constant, and we can distribute this as 3y squared minus y cubed dy. Alright, and the value of y can change from y equal to 0 to y equal to 3. Is that right? The height of the tank is 3 meters. So y can change from y equal to 0 to y equal to 3. Therefore, the total work done is obtained by integrating this dW from y equal to 0 to y equal to 3. Let's do that over here. That is W equal to integral 0 to 3, this is constant, y squared times 3 minus y dy,